Alrighty, a continuation from 5.3a, Math 20-1. We are going to be continuing with radical equations, and so we're still going to be solving equations with square roots on both sides and figuring out the roots algebraically. Still going to be identifying restrictions for the value and use that to be able to solve and model radical equations, or problems with radical equations. So how do we deal with radicals on both sides of the equation? Remember, whatever you do with an equation, you can do whatever you want with it as long as you do it to both sides. So if you have a square root on both sides, a nice easy approach to this is to square both sides. So we're going to square the 3x plus 4, and we're going to square the root 5x minus 6. Now, a square and a square root, they cancel out, and you'll be left with 3x plus 4 equals 5x minus 6. And then you solve this using algebra. Now I want to have a positive x, so let's bring the 3x over to this side, and by subtracting 3x from both sides, we'll be left with 4 equals 2x minus 6. Then we'll bring this 6 over to the other side to make that positive by adding 6 to both sides, and we'll have 10 equals 2x. Finish isolating the x by dividing both sides by 2, and you'll find that 5 equals x. Now we want to do two things here. We want to, one, identify the restrictions for these two values. It's going to be two restrictions we need to identify. So if we want to find out what would make we have to make 3x plus 4 greater than or equal to 0. So bring the 4 over to the other side by subtracting 4 from both sides, and we'll have 3x must be greater than or equal to negative 4. And then divide both sides by 3 to find that x must be greater than or equal to negative 4 over 3. Also, we need to find that x must be greater than, or 5x minus 6 must be greater than or equal to 0. So add 6 to both sides, and we'll find that 5x must be greater than or equal to 6. Divide both sides by 5. X must be greater than or equal to 6/5. Now, x has to be greater than 4/3, but it also has to be greater than 6/5. So the values in between negative 4/3 and and 6/5, those won't work. So say we had a value of 0. If x was 0, it might satisfy this side of the equation, but it would make this a negative number, and that would be no good. So if like 5 times 0 minus 6, that's a non-permissible value. So x has to be greater than or equal to 6/5 in order to satisfy both sides of the equation. Now we're going to verify this as well, just to make sure that value does work. There are some odd occasions where your value that you find will actually not satisfy your restrictions, and in that case the equation needs to be discarded. But for the most part, those are avoided. So verify by substituting in 5 into our original equation. So 3 times 5 plus 4 equals 5 times 5 minus 6. So 3 times 5 is 15. 15 plus 4 is root 19. And this should equal the same on both sides. 5 times 5 is 25. 25 minus 6 is also root 19. So it verifies, checks out, the value is greater than, or the value fits the restrictions. That's a good equation with a valid solution. All right, so if you were to square both sides in this example, you would end up with two binomials um, that you're squaring, and you would have to use FOIL on both sides, and that turns into a bit of a mess. So if you can, simplify anything that you can first. You've got this 7 and this 5. Try and stick with positive numbers if you can. It won't make a difference which side you put this on. But I'm going to subtract 5 from both sides first. Just to make it so I only have the square root on one side. If you do that, the numbers will come out nice and neat. If you try to just square them from the start without simplifying some of your terms, the numbers get quite messy. So let's bring this 5 over to this side by subtracting 5 from both sides, and we'll have 2 plus root 3x, and that equals root 5x plus 4. Now that we have a side that only has a square root, this one will simplify much better, as you'll see, rather than this one. This one's going to leave us with a square root. So squaring both sides is going to eliminate square roots that are by themselves, but not eliminate a square root that is not by itself. So let's see what that looks like. So square both sides, so 2 plus root 3x squared is equal to root 5x plus 4 squared. And so this binomial here, you're going to need to expand that out, because this is 2 plus root 3x times 2 plus root 3x. Remember, when you're squaring a number, you can't just put in the square for each of them. This doesn't turn into 4 plus 3x because you're squaring this whole side, not just the individual terms. So you end up with this binomial, these two binomials that you'll need to distribute into each other. And you'll see that we're still going to be left with a root over here. If we left the two binomials, we're going to be left with a root on the left and a root on the right, and we haven't really made any progress in the equation. So let's have a look at what happens to the right side, though. When we have a radical that's by itself on one side of the equation, and we square it, squaring and square rooting cancel out. So look, we've managed to at least get rid of that radical. Now let's distribute. So distributive property, we're going to multiply everything in here with everything in here. 2 times 2 is 4. 2 times root 3x is 2 root 3x. And root 3x times 2 is 2 root 3x. And root 3x times root 3x. You're squaring the number, so the root's going to cancel out, and you'll be left with 3x. And then on our right-hand side of the equation, we've got 5x plus 4. Okay, let's combine together some things, and we're gonna, in one step, we're gonna keep our radicals together here, but this 4 and this 3x, let's combine it over into the other side. So let's subtract 4 from both sides, and the 4 and the 4 are going to cancel with each other, and we're going to move the 3x. Let's just do one step at a time. Let's bring the 4 over. It's going to cancel out, and we're also going to combine together these two. So let's do 4 root 3x. So 2 root 3x plus 2 root 3x is 4 root 3x. And then we still have the plus 3x equals 5x, and we subtracted 4 from both sides, so those cancel out. Let's bring the 3 over here by subtracting 3x from both sides, and we'll have 4 root 3x equals 2x. Now we still need to get rid of this root 3x. So we have to square both sides again. I'm going to start another row here. And if we square both sides again, we'll finally get rid of this. We'll get rid of our second root. So, but notice how we have no binomials here. So we're not going to end up with this situation again where we end up with another root. And the key to that is, the key to getting rid of a root is making sure that it's by itself before you square both sides. So 4 root 3x squared equals 2x squared. So when you're using a binomial, when you're squaring a binomial, you need to multiply the whole binomial with the whole binomial. When this is a monomial, though, this is just one term. So this is 4 root 3x times 4 root 3x. And then this is equal to 2x times 2x. So remember, when you're multiplying radicals, you multiply the coefficients with each other. So 4 times 4 is 16. And then you multiply what's under the radical with each other. 3x times 3x would be 9x squared. Notice how this is a perfect square. So we can actually eliminate that. And root 3, of course it should be root 3x times root 3x is, well, you're squaring that value and you're square rooting it, so it'll cancel out. So 2x times 2x, just like we do with radicals, do the coefficients with each other and do the variables with each other. X times x is x squared. All right, so square root of 9, or let's keep our 16. Square root of 9 is 3, so times 3, and square root of x squared is x. And that is equal to 4x squared. 16 times 3 is 48x, and that's equal to 4x squared. So we have two values for x here. Let's bring the 48 over to the other side, and that turns into, so we'll make it 0 equals 4x squared minus 48x. And we'll factor this. We can take a 4 and an x out of it. So 0 is equal to 4x. Take that value out of there, and we're left with x minus 12. Now at this point you can divide both sides by 4x. We've got this handy 0. You definitely want to get one side equal to 0 whenever you're faced with some sort of quadratic, because in this case we can divide both sides by 4x, which makes it easy. In some cases you'll need to use the quadratic equation to solve your values of x. So divide both sides by 4x, and 0 divided by anything is just 0. 4x divided by 4x leaves us with just x minus 12. And we can finally solve this by bringing the 12 over to the other side, leaving us with 12 equals x. So something we need to check here, we need to check the restrictions. So, and then we'll verify. So the restrictions are, so we want 3x must be greater than or equal to 0. Divide both sides by 3, and we find that x must be greater than or equal to 0. That's one of them. The other one is that 5x plus 4 must be greater than or equal to 0. Bring the 4 over to the other side by subtracting 4 from both sides. Find that 5x must be greater than or equal to negative 4. And divide both sides by 5 to find that x must be greater than or equal to negative 4/5. So remember, having these two restrictions, one of them kind of becomes invalid. If x were to be something in between these, it would satisfy one of them but not the other. So if x was, say, negative 1/2 would be in between 0 and negative 4/5, negative 1/2 would satisfy this, because x would be greater than that, but it wouldn't satisfy this value, which throws off this term right here. Nope, this one? Yeah, this one. And that's no good. So let's also verify and make sure this is a valid solution by substituting in our value of 12 into both sides of the equation. And again, sometimes it won't. And then the equation has to be discarded, but so 7 plus root 3 times 12 equals root 5 times 12 plus 4 plus 5. All right, so 7 plus 3 times 12 is root 36. And 5 times 12 is 60. 60 plus 4 is 64. And plus 5. So root 36 is 6. And root 64 is 8. 7 plus 6 is 13. And 8 plus 5 is also 13. So 12 does fit the description of both of these restrictions. 12 is bigger than 0, and it is bigger than negative 4/5. And the equation checks out. So this is a valid solution that fits the restrictions. All right. So if we, like I said in the last one, if we have two radicals, the goal would be to get one of these two to be by itself. And if we have this negative, the one that I'm going to choose to move so that it's on the other side of the equation is probably the negative, because then I can add that to both sides. So if I had root 4x plus 5, I'm going to add root 2x minus 1 to both sides. So let's write this out. So minus 1 so you can see what it looks like. So plus root 2x minus 1. So I'm adding and subtracting the same value. I'm doing that on purpose to cancel it out on the left-hand side. But I'm going to have this binomial on the right-hand side. So this cancels out. The advantage that's gained, though, is that now on the left-hand side of the equation, we have a radical that's by itself. And then over here, we've got 2 plus root 2x minus 1. So let's square both sides. And so square both sides. And the square on the left-hand side with the square root is going to cancel out, and we'll be left with 4x plus 5. But on the right, it doesn't just cancel out because it's a binomial. We'll need to expand that out. So that turns into 2 plus root 2x minus 1 times another 2 plus root 2x minus 1. And we'll need to use FOIP and distribute those two terms. So 2 times 2 is 4. 2 times root 2x minus 1 will be 2 root 2x minus 1. And root 2x minus 1 times 2 is 2 root 2x minus 1. And root 2x minus 1 times root 2x minus 1, you're squaring it, the square root will cancel, and you'll be left with 2x minus 1. Okay, we've gotten rid of one of our square root values. These two are combinable because they have the same radicand. So let's combine together what we can. Let's bring over, in the same time, 4 minus 1 is 3. Let's bring that 3 over to this side with the 5. and deal with a bunch of the, let's deal with the constants and bring it down to just one constant term. So 4 minus 1 is 3. Then we want to get rid of the 3 on the right side by subtracting 3 from both sides. So we'll be left with 5 plus 2, and then we've managed to cancel those two values out. 2 root 2x minus 1 plus 2 root 2x minus 1 will be 4 of those. So we'll have 4 root 2x minus 1s. And then we still have 2x. And our next line would be, with subtracting 2x from both sides, we'll have 2x plus 2 is equal to 4 times root 2x minus 1. Now, we want to square both sides in order to get rid of this second square root. So let's throw up a little divider here and start a new line here. And we're going to square both sides. So 2x plus 2, plus 2. And squared. That's a binomial that we're going to have to square, and we're going to end up with a trinomial equals 4 times root 2x minus 1 and squared. So we'll have to expand this out, and it turns into 2x plus 2 times 2x plus 2, and that equals, and so when we're squaring this, we need to square both these pieces. Kind of like if you had 4x squared, you would multiply the 4, you would square the 4, and you would square the x. So let's square the 4, and we end up with 16. If we square the square root of 2x minus 1, we just have 2x minus 1. Now this is 4 times this radicand, 4 times this value. So we are getting rid of the square root here. But the 16, this multiplier still needs to be distributed to that value. So the 16 is multiplied to both of them. So we'll come to that in a sec. 2x times 2x will be 4x squared. 2x times 2 is 4x. 2 times 2x is another 4x. And 2 times 2 is 4. Let's distribute the 16 to both these terms. 16 times 2x is 32x. 16 times negative 1 is 16. Let's combine together our like terms. So on the left-hand side, we'll have 4x squared plus 8x plus 4. And on our left-hand side, we have 32x minus 16. So let's bring, since we have a quadratic, we want to set it up so we have our quadratic equal to 0. So let's bring over the 32 by subtracting 32x from both sides. 8x minus 32x will be minus 24x. And then we'll bring the 16 over by adding 16 to both sides. So 4 plus 16 is 20. Now on our right hand side we have our 0. And we can deal with this quadratic. So remember, when we have a trinomial, if you have a common factor, don't forget to pull those out first. It's going to make all your numbers easier. If you use the quadratic equation on this, then it would still work out, but your numbers would just be a lot bigger. All of these are divisible by 4, so let's pull that 4 value out so that our quadratic is easier to manage. So divide all of these by 4, and you have this. So something to do with the trinomial, if you can, check and see if there's a nice easy way to factor it. Are there two values that you can multiply together to give you 5 that also add together to be negative 6? And yeah, so instead of doing the whole quadratic equation, if you can skip it, you might as well. So if you did negative 5 times negative 1, that would add together to be negative 6, but also multiply together to be 5. So without a coefficient in front of the x squared, this turns into x minus 5 times x minus 1 equals 0. So our x value, when we have it set up like this, if you remember from our graphing units, x is equal to 5 and x is equal to 1. Now let's do the quadratic equation on this just to confirm it. So the quadratic equation is x is equal to, just in case you went with this route, so x is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. So x is equal to negative of negative 6 plus minus negative 6, square root of negative 6 squared minus 4 times 1 times 5 all over 2 times 1. So our x is going to equal, that becomes positive 6 plus minus, and then this is 30. Underneath the root is 36 minus 20 all over 2. So our x is equal to 6 plus minus, and then 36 minus 20 is 16. Square root of 16 is 4 all over 2. So our two values there, so x is equal to 6 plus 4 is 10 divided by 2 is 5. 6 minus 4 is 2. 2 divided by 2 is 1. So it is confirmed here. So those are two possible solutions for x. So just to do the the restrictions, we got to do those still. So the restrictions, just to check and see if our solutions match, we want to see, we know that 4x plus 5 must be greater than or equal to 0. Bring 5 to the other side, and you get, bring 5 to the other side, and we'll find that 4x must be greater than or equal to negative 5, and then divide both sides by 4 to find that x must be greater than negative 5/4. Our other restriction is under here, so this 2x minus 1 must be greater than 0. Bring the 1 to the other side, so 2x must be greater than or equal to 1, and divide both sides by 2 to find that x must be greater than or equal to 1/2. So if x has to be greater than 1/2, and x has to be greater than negative 4/5, x has to be greater than or equal to the 1/2. Because if it was some term in between these, it would satisfy this value, but not this one, and we would have a negative square root. So x must be greater than or equal to 1/2. And we also want to verify. Either of these terms should go in there. And remember, if one of them doesn't work out, that's an extraneous root. So let's first put in the 5 into the equation. So root, running out of space here, 4 times 5 plus 5, and then minus root. Sorry, I should also mention both this 5 and the 1, they both satisfy the restrictions. Meant to say that in there as well. So anyway, 2 times 5 minus 1, and then that is equal to 2. All right, so underneath the first root there, 4 times 5 is 20, plus 5 is 25, then minus. 2 times 5 is 10. 10 minus 1 is 9. So that should be equal to 2. Root 25 is 5 minus root 9 is 3. And 5 minus 3 is indeed 2. So 5 works. Do our last one. Just gonna move this over because I need that space. So let's check with the 1. So 4 times 1 plus 5. And then we're minusing root 2 times 1 minus 1. And that's equal to 2. So underneath here, 4 times 1 is 4, plus 5 is 9. 2 times 1 is 2, minus 1 is 1, equals 2. Root 9 is 3, root 1 is 1, equals 2. 3 minus 1 is 2, that does indeed equal 2, so there's no extraneous root for this. Alright, one for you guys to try. Here's a good spot to pause and give this one a go and see how you do with it. I'll solve it now though. So, again, we want to multiply both sides, or sorry, not multiply, we want to square both sides. If we have a value that is a square root by itself on one side, by squaring both sides, we're going to get rid of that square root. So let's square both sides. And we will end up with a binomial on the right, but that's okay. It's going to get rid of one of our squares. So we'll have actually, you know what? Scratch that. No, we do need to square it. Sorry. So x, sorry, I thought of a different solution, but so squaring and square rooting both sides, we'll be left with x minus 1. And then squaring this, we're going to have our binomial of x, root x minus 1 times root x minus 1. So on the left-hand side, we've still got our x minus 1. Root x times root x will cancel out, and we'll just be left with x. Root x times negative 1 will be negative root x. And then negative 1 times root x will be negative root x. And then negative 1 times negative 1 is plus 1. So put some of these things together. Let's bring the x term over here by subtracting x from both sides. And you'll notice that the x's cancel out with each other. So we'll subtracting x from both sides will cancel out our x term altogether. So we'll be left with negative 1, and then negative root x minus negative root x will be negative 2 root x, and then plus 1. Let's bring this one over to this side because it looks like we're just going to solve for x in this case. So subtract 1 from both sides and you'll get negative 2 is equal to negative 2 root x. 1 minus 1 is 0. Now we can continue isolating for this x. Divide both sides by negative 2. These cancel and you're left with 1 equals root x. Now if you square both sides, you'll have 1 squared equals root x squared. 1 squared is 1. The root of x squared is just equal to x. And we have 1 equals our x. Well, let's verify and make sure that's, let's look for restrictions and make sure that fits. Let's so for our restrictions, so underneath this root, we know that x minus 1 has to be greater than or equal to 0. So bring the 1 over to the other side, and we find that x must be greater than or equal to positive 1. And underneath this one, the x must be greater than or equal to 0. So again, the one that actually matters the most here is that x has to be greater than or equal to 1, because if it was something in between this, it might satisfy this, but it wouldn't satisfy this one. So this is the important value. Now let's verify, make sure that all works out. Let's verify this term to make sure it is a valid solution. So we got one value for x, so we only need to do this once. Let's put in that 1 into both sides of the equation. So square root of 1 minus 1 equals square root of 1 minus 1. So 1 minus 1 is 0, square root of 0. Square root of 1 is just 1 minus 1. Square root of 0 is 0. 1 minus 1 is 0. That checks out. Alright, that's all for this one. Thanks for joining me. Till next time.